Hello, my name is Professor Dolores Knapp from the University of Colorado Boulder. I teach in the SMED Aerospace Engineering Sciences Department and have affiliations with Space Weather Technology Research and Education Center and the Colorado Center for Astrodynamics Research. I'm also putting this together as the chair of the CEDAR Science Steering Committee because as I have come up through CEDAR in the last 30 plus years, I recognize that sometimes there's not a lot of resources for the beginning students, and sometimes even for the more seasoned scientists. So I got together with Professor Trey Cade from Baylor University and Professor Jens Oberheide from Clemson University, and together we came up with a list of about 40 textbooks that, while no single one covers all of the regions of the CEDAR science, as a unit or as a collection, we think that you can probably find some information that you might need. So as you're attending CEDAR, some of you for the first time, some of you for second or third, or if you're actually a seasoned attendee, you probably realize that as you go to the sessions virtually as they are, that you are going to hear a sea of words. They're going to meld into kind of an ocean of ideas at CEDAR, and sometimes you probably want to step back and say, gosh, where could I learn a little bit more about that? And of course, you can always go do a web search and go to Google, but sometimes you want something that's maybe a bit more permanent. So I've decided to try and disaggregate these concepts and ideas that you're going to hear about and present them in an order that at least makes sense to me. About 40 of them. They're textbooks or text resources. Not all of these have end of chapter problems, but many do. And they cover the places and processes that connect regions that CEDAR scientists study. Many of these are cross-disciplinary, and that cross-disciplinarity extends into the types of measurements that CEDAR scientists may want to make, the data science that we need to use to process large data sets, and applications that we might make to different disciplines, including engineering. So CEDAR science is kind of bookended here between earth science and solar studies. It has an element of meteorology and climate, a really strong component of something called aeronomy and space weather, where aeronomy is meteorology of the upper atmosphere. Certainly particles and fields and plasma come into play. And then these cross over into other ideas like radars and lidars. So those are instruments that measure quantities of interest to CEDAR scientists. We also put instruments on platforms like rockets and spacecraft, the GNSS that we're going to send to space. We need to process these measurements with statistical methods very often. There are other techniques that are used in CEDAR science that are closely related to imaging and spectroscopy. And then with all of the data that we gather, sometimes it's so voluminous that the best thing that we can do is apply artificial intelligence or machine learning. So I'm going to try and take you through an ordered process of these textbooks that starts low, goes high, and then extends over into these disciplines. So I've essentially created a virtual cross-discipline bookshelf for you. And so not only is there this video, but I will be uploading other material, some PDFs, so that you have hard copies of this and also a hard copy of a variant of this that has the table of contents for all the textbooks that I've been able to find and put online. So let's start where I started, which is in the world of meteorology. I did my undergraduate work in meteorology. And of course, most anyone who does that will have read a textbook by Holton, perhaps, Introduction to Dynamic Meteorology. It's in its 5th edition. I think I started with the 1st or 2nd edition. A little bit more in terms of fluid dynamics, you can go to geophysical fluid dynamics, or you can go to dynamics in atmospheric physics. The first two of these are relatively recent. This one again, 5th edition. 1990, that's where you'll find a lot of the textbooks, right, that are part of CEDAR science. If we go a little bit higher into the CEDAR domain, we start talking about aeronomy or meteorology of the middle atmosphere, and also considering chemistry and physics of the stratosphere and mesosphere. Middle atmospheric dynamics. So if you don't know what stratosphere and mesosphere is or are, well, they're part of the middle atmosphere, the place above the troposphere where meteorology is the primary discipline, going all the way up into these regions, kind of the rarefied regions, where you even have to start to think about ionospheric physics. Some of the processes that connect the lower and upper atmosphere have to do with waves and tides and waves, and certainly with chemistry that in some cases is driven by solar processes. And all of these end up then kind of linking to material in the upper atmosphere. So there's probably the oldest textbook on this list is Atmospheric Tides by Chapman and Lundzen, 1970. It would be great if that got updated, but and perhaps it has been a little bit when we go to this textbook on atmospheric tidal and planetary waves. And then you may recognize that one of the types of waves not mentioned here is a smaller scale wave called atmospheric gravity wave. So there's an introduction to that. As I mentioned, there's physics and chemistry of the upper atmosphere, and then theory of planetary atmospheres, which has a couple of really relevant chapters for CEDAR on Earth atmosphere. Both of these are written in about 1990. I'll tell you that is a significant time frame. It's a time frame when people started becoming really aware of the upper atmosphere's role in the developing discipline of space weather. So there were a number of textbooks on this page, and you'll see later that were published about that time frame. So let's go a little bit further out and start thinking about Earth's ionosphere, which is the weakly ionized portion of Earth's atmosphere, which can be strongly driven by electric fields, so hence the title Electrodynamics at the end of this textbook by Mike Kelly. Ionosphere plasmas, physics, plasma physics and chemistry, a little bit more advanced textbook. One of my favorites is Physics of Space Physics, Plasmas, an introduction. That was written again in that time frame that I mentioned, 1991, but has recently come online as an ebook, so I recommend that. Another book written in the 1992 time frame is written by Hargreaves, kind of a very general exposition of the solar terrestrial environment. Mike Kelly wrote another textbook on Earth's electric fields. Certainly that deals with fields that may be at the ground going all the way up. There's another textbook that I like, Basic Space Plasma Physics. I don't think it has any end of chapter problems. I've had trouble finding it as an electronic version, but I believe it is readily available on any of the online publishing warehouses. If we extend our view out now to the space environment and space weather, there are a number of textbooks that recognize that the CEDAR discipline is contributing in that area. Introduction to Space Weather by Mark Moldwin is a fairly basic textbook. And then the next two are more at the upper division undergraduate textbooks level. Space physics, space weather and physics behind it, and space physics and introduction certainly are getting into the late stage undergraduate and beginning graduate student realm. And then space physics and introduction to the plasmas and particles in the heliosphere, pretty much the same thing. And it is a book written in 2004. Taking this a little bit further into the getting a textbook that's perhaps a little bit more advanced and thinking more about the disturbances, there's Physics of Space Storms. Mike Hapgood has written a textbook. Well, it's a textbook. It's actually only about 30 to 40 pages. It's a really nice introduction to some of the terminology that gets used in space weather. It's online only, and it's free access. There's Physics of the Earth Space Environment. That's a reference textbook I use for my class, and it certainly has some very good introduction to lower atmosphere physics. Physics of the solar system reaches a little bit more into the magnetosphere and the solar wind, and then Physics of the Space Environment covers all of these. It's a slightly more advanced textbook. There's a recognized need for understanding how all of these things link together beyond CEDAR. So here is a series of textbooks that have been supported by NASA that you can see the titles of 4 of these. These are all coming from Cambridge University Press, both hard copy and I think soft copy. Heliophysics 5, Space Weather and Society is currently online only, so I give you the link right here. It's also free access. Moving over to the realm of statistics, applications, and measurements, if you need to do a statistical analysis, there's some pretty good background information in this textbook by Wilkes. If you need to think more about how radio waves might be propagating through or under or in the ionosphere, this book by Hansucker and Hargraves is a pretty good one. Spacecraft environment interaction deals more with space environment and hardware. If you want to look at the upper atmosphere and kind of look at it through a whole range of wavelengths, then I recommend this spectral imaging by Gordon Shepard, who used to be a very regular attendee at CEDAR. And then you can also head over to the realm of plasma physics with laboratory applications by this book by Don Garnett and Bhattacharjee. One more listing of space applications books. I really like this textbook. I use it as a reference in my class. It's more from the engineering perspective, space environment and effects on space systems. Also in the applications world is space weather and telecommunications. There's a relatively new book on ionospheric prediction and forecasting from our European colleagues. And then I was pretty sure I needed to give you at least a hint about where to go for global navigation spacecraft systems, so remote sensing. So here's a theory, methods, and applications that has a good chapter on the relation to the ionosphere. And then a lot of you, as you move into your scientific careers, are probably going to be looking at processing a lot of data. So I wanted to mention this book by Enrico Camprielli, Simon Wing, and Jay Johnson for machine learning techniques for space weather, not just for space weather, but also for CEDAR science. Here's a list of additional references that I'm not going to read to you. If there's one that is free access, I pointed that out. These kind of fill some gaps or address some regions that you might need to read about more in the magnetosphere or geomagnetism, so they're listed here. And I also want to highlight this reference that Trey Cade and I put together for space weather that now is, I think, pretty comprehensive. We're going to upload it, redo it one more time, but we've used the publication site Zenodo. So if we redo it, just using this particular DOI, we'll get to the latest version. And it now contains or will contain a lot of the information I presented here, plus a much more comprehensive look at some of the solar and magnetosphere and books, and also books that are published under the realm of AGU or International Space Science Institute as one of their sets of or volumes of publications. So just to quickly summarize, I know as a student when I entered attending CEDAR's meetings in the late 1980s, I was pretty overwhelmed and was just going, oh, please somebody just provide me with a book I can read. So unfortunately, there is no single book, but I hope I have at least organized for you books and provided them either in space or in order of level of difficulty, so that you can go look up terms yourself or look up ideas or see how things are stitched together in terms of concepts. I also plan to provide, but have not yet done so, a version of this presentation that contains tables and contents and web links to those tables of contents. That'll come in a secondary PDF. The reason I think that's valuable is it takes you straight to the publisher's website, and you don't have to endure all of the ads of Amazon or Google if you don't want to. Of course, if you do want to, then that's your choice. So as I've said, I've put together a list of about 40 textbooks that cover the realm from low to mid-atmosphere, going all the way out into the space environment, and also give you a hopefully useful sampling of textbooks related to CEDAR science that deal with statistics, applications, and measurements, and that additional reference list. So if you think I've missed something really important, please feel free to contact me at this email address. And I hope this presentation gives you a good reference shelf so that you can go to as you advance your career in CEDAR sciences. So thank you very much.